So without further ado, I want to introduce Rodrigo Aramburu, who's our speaker here. He's going to give a really great talk about all things GPUs and data science. So what I'll do is I'll turn it over to Rodrigo now, and then we're going to mute everybody's mic so that way he's got the floor. If you have some questions, put it in the chat window, and then we'll address them at the end, and then we'll all come back after that. So enjoy.
All right, well, thanks, Aaron. Here, I'm gonna put my screen share.
Oops, I think I muted him too, shoot.
Okay, how about now? Can you hear me now?
Yeah, I muted you. I muted everybody and you. Sorry about that.
That's groovy, no worries. I'm guessing you guys can see my screen now, right?
Yep.
Okay, well, just to introduce myself, thanks, Aaron, for the introduction. I'm Rodrigo Aramburu. I'm the co-founder and the CEO of BlazingSQL. And basically, we've been working on GPU accelerated SQL for about 6 years, which puts us basically at the beginning when a lot of GPU accelerated SQL started coming out for the first time. We thought about it very differently. And about 2 years ago, or a little over 2 years ago, we started working on an open source data science ecosystem for GPUs with NVIDIA. And that work ended up building the fundamentals of our now open source SQL, distributed SQL engine. So real quick things here. Check us out on Twitter if you want to hear about what we're doing, what's going on. We post all sorts of information about BlazingSQL at Twitter, so at BlazingSQL. If you have any questions after this talk, you can message me directly, Rodrigo at BlazingSQL. And yeah, we'll just get into it. So to kind of start things out, it's really important to understand Rapids and what Rapids is about. So for anyone not necessarily familiar, Rapids is a GPU data science ecosystem where you can do end-to-end workflows from raw data living inside, maybe it's AWS S3 buckets and a bunch of Apache Parquet files, or thousands or millions of CSV files, what have you, all the way down to whatever it is that you're trying to do. So you have to do ETL to that data, and then maybe you have to do some machine learning, you have to do visualization, you have to do graph analytics, deep learning, etc. But keeping it all entirely inside the GPU has always been kind of like the big thing about Rapids. And what that enables it to do is to run dramatically faster. You can use a lot less hardware to be able to do big scale analytics. And that's really like the whole purpose of Rapids and the Rapids ecosystem. Real fast, everything in the Rapids ecosystem is open source. Apache v2, super permissible licenses. Everything in the Rapids ecosystem is GPU accelerated. That's obvious because NVIDIA is the largest contributor. We're the second largest contributor to Rapids. And then the other big thing about it is the APIs. So many of the APIs and the packages that have been created in Rapids mirror PyData ecosystem or similar, a lot of really common popular APIs. So the whole idea is to be able to just take the code that you know and love today, change out some import statements ideally, and that'll just run on GPUs dramatically accelerated. Now, that's the pitch, and you can do a lot of things like that, but this is a 0.14 project. So there's obviously still a lot of things that we have to build out, but it can do a lot of that. To quickly kind of go over the Rapids ecosystem, this is just kind of like a high level, and this isn't even really exhaustive anymore of the whole ecosystem because there are just so many components that exist now. But these are kind of the original few. And what really matters about this whole ecosystem is that there's basically a data frame that's held inside Apache Arrow GPU memory. And what that means, or what that enables us to do, is that we're able to very performantly hand off data frames between all the different libraries inside the ecosystem without having to copy the data between them, without having to serialize the information between them. And it just makes it just a holistically more seamless experience. So we're the SQL engine of this entire ecosystem. So we're SQL on data frames is the easiest way to think about us. cuDF is the pandas-like API. So for ETL, pick your poison. It doesn't matter which you really prefer. If you prefer pandas, there's a pandas-like API. If you like SQL, there's a SQL API. And that's like the two main ETL libraries. cuML is scikit-learn on GPUs, also mirrors the APIs. cuGraph is NetworkX, if you're familiar with NetworkX for graph analytics. And then there are plugins to PyTorch, Chainer, and a bunch of other deep learning stack, as well as visualization. And this really isn't all of it. There's also now, there's a cuSpatial package, which is all about GIS on GPUs. So, if you're trying to do things with 5 million or 100 million geo coordinates, like it's incredibly fast and highly performant. There's also cuSignal, which is for like signal processing. There's a bunch. There's new projects being added all the time. And the entire impetus for building out this ecosystem and this stack was trying to figure out a way that we can enable Python data science to not just be performant in the small scale factor, for a couple of gigabytes, but how is it that you scale it up effectively to terabyte workloads? And something that's here, right, is Dask. So Dask is really consequential in making that happen. And Dask is basically what brings this whole ecosystem together to run on multi-GPUs. So, maybe I want to start out with one GPU on my laptop to start playing around, but then I can start taking it further and further with more GPUs using Dask. So kind of just like a really good demonstration of why this ecosystem matters. The way that we always pitch it is faster, cheaper, easier. That's the whole idea. Most of the time when people hear GPUs, cheaper is the last thing that they think, because GPUs are really quite expensive pieces of hardware. But if you know how to utilize them and utilize them effectively, you actually could have a dramatically lower cost of ownership for a variety of workloads. So this right here is a benchmark by this organization called TPC. And their benchmark, TPC XBB, is their big data benchmark. And basically, there are 30 workflows. The data set mirrors a retail and e-commerce store. And what they basically do is they have these 30 different workloads, and those workloads will be from ETL to natural language processing, ETL to machine learning. It's all a variety of different workloads that try to mimic what this retail and e-commerce site would necessarily have to do. And it lets you just scale up the data sets to really large data sets. So we ended up running this benchmark, and the current winner for 1 terabyte space is Huawei with Cloudera implemented on it. And for about half the price, so they were costing, about 280,000 for their 16 server cluster, we were able to do something on half the price worth of infrastructure. And we're on average about 44 times faster on this particular workload. This is a log scale chart. So it's, bear in mind that this here is like 44x faster. This here is like 200x. I kind of just picked 5 of the workloads. I picked the 2 fastest, or the two that had the biggest speed up, which are these 2 over here, which are in like the 200 range. The 2 with the slowest speed up, which are, like 5 to 10 sort of speed up range. And then this one's about the average 45, like 45 times faster. But that's really what the whole concept of this ecosystem is, right? It's about, 1, can we run the workloads faster? 2, can we run the workloads cheaper? And then when we start thinking about easier, that's really what comes up in the next parts of this. So data frames on GPUs is kind of like the first thing we like to talk about, just because it's the first part of a data science pipeline. And cuDF is really kind of like the thing that connects everything in the ecosystem together. So it's pandas on GPUs. That's literally the easiest way to think about it and how it works. And so here, this is just a really simple code snippet showing what it's like to write it if you know pandas, which for this meetup, I'm going to assume pretty much everyone here does, or at least 90% of us do. This should look very obvious and simple to you. It's just the .read CSV, and it's a data frame. And this is entirely on GPU memory. Some really good numbers. These are all numbers from NVIDIA. So, GPU speed up over CPU. They normally try to find a server class CPU with a server class GPU to do these kind of comparisons. But across a variety of different workflows, right, or algorithms, you'll see that the speed ups are almost 3 orders of magnitude in some cases. And that's really just like, this is the data frame. It's on GPU. You're able to operate on it a lot faster. And then you can hand off that data frame kind of like pandas to anything that supports the ecosystem. Blazing is SQL on data frames. So that same data frame that we did previously, or we showed off previously, we can also just pass that as a table. And if we name that as a table inside BlazingSQL, we can effectively just write SQL on top of it. We leverage an open source project called Apache Calcite, which is our SQL parser. So we're actually ANSI SQL compliant. Compliant does not mean complete. So there's still, SQL functionality that we don't enable, particularly DDL, if you're familiar with SQL. So, any data definition language, all of that's Pythonic for our engine. The entire engine itself, that's probably something I should have mentioned at the beginning. The entire engine itself is a Python engine. So you can't install BlazingSQL. You're not connecting it to a database or a SQL engine or something that exists somewhere else. That package has everything in it. And then you're literally going to just be calling Python functions to run SQL. And I'll show that off in some demos in a few minutes. This is basically just an explanation about out-of-core. I'm not going to get too into this. What really matters in this particular slide is that BlazingSQL knows how to operate and cache in between execution kernels. So if we have a query execution plan on, let's say, a terabyte of data, and we only have one GPU on our laptop, but we have a ton of, let's say, disk space, we're able to cache either, to system memory or to disks, to drives, right? As we're doing execution. So you can scale up pretty aggressively, even if you only have few GPUs. So something that really happens, particularly in cuDF, is that cuDF expects everything to fit inside of a GPU whenever you're operating on it. And so we're using the same primitives as cuDF, but we break up on SQL land. It's a lot easier to break up, how to work on these particular things or how to work on a SQL plan. And so we've done it so that you can basically be operating on these out-of-core queries. We actually have a blog post that talks a little bit about a 10 terabyte workload that we did on one GPU. It obviously runs slower. You want it to go faster, you have to add more GPUs. But that's how that works. Real fast. So Dask is kind of the thing that brings it all together when we're trying to think about scaling out this GPU architecture. So when it comes to pandas, for example, on GPUs, the cuDF library, very similar to a Dask data frame, is made up of a bunch of partitions of pandas data frames. There's a very similar implementation called Dask cuDF. And Dask cuDF is a top-level project inside the ecosystem. It's wildly important. And it's how all of these cuDF data frames are handled in a partitioned environment. So if I have 8 GPUs, I'll have 8 partitions of cuDFs that with one of them residing on each GPU, each worker, effectively. BlazingSQL also leverages Dask cuDF. For one, this distributed data frame. So if you run a BlazingSQL query, the results of a BlazingSQL query aren't going to be brought back to a single worker. Depending on the type of SQL query that you have, it might be the results that might be distributed across your array of workers. And when we do that, we don't create just a cuDF, we have a Dask cuDF that has it on the other side. The other thing that's really interesting about Dask is how we maintain awareness of the cluster. So you don't tell BlazingSQL to run on 10 different GPUs or 10 different servers. You simply create a Dask client that has awareness of has Dask workers on all those different GPUs, and BlazingSQL will just learn where all those workers are, and then launch a BlazingSQL worker process on all of them. And Dask is really what enables that to work. So we don't just use it for the CUDA data for the partition data frame. We also use it for that. And then DaskQML is basically, just like DaskML, except leveraging DaskQML. For anyone who's not familiar with DaskML, it's a distributed version of a bunch of machine learning projects. DaskQML does the same thing. So you can effectively think of this as like scikit-learn with Dask, but it's all running on GPUs. And it can also take these, Dask data frames that are partitions of cuDFs. And that's how Dask kind of brings this thing into this ecosystem. I'm going to real quickly go over machine learnings, and then I want to bring up a demo so everyone can follow along. QML, like I was saying, is scikit-learn or sklearn for GPUs. So anyone who's familiar with sklearn, literally, if we just changed out the text in red here, this would totally function. The only difference is that this is happening on GPUs. And that's the whole proposition of like this workload. So we can, create data frames off of raw data, ETL it, transform it, do all sorts of things, and then hand it off to QML for doing machine learning. Just real quick, showing off a variety of different things that have already been implemented in QML. These are a variety of the different algorithms that you can get. And they're growing by the day. There's a pretty big team at NVIDIA that actually writes a ton of this, incredibly smart crew. And yeah, all of this is a really interesting project inside the Rapids ecosystem. Before I go, instead of going over more slides, I kind of want to just show off some demos of how this all works. And one of the cool things is that people can follow along if they would like to. So if you go to app.blazingsql.com, what you're going to have is basically, it's an app that has a hosted JupyterLab environment. It'll create a unique private JupyterLab environment, but we're all going to be sharing GPUs across a cluster of GPUs. So if anyone feels like during the demos querying a giant data set they know about, you might crash a friend or two and be a nasty neighbor. So just keep that in mind. But otherwise, you're more than welcome to sign in. You have to have a Google account. That's one of the things that you have to do. But you can see how this whole thing works. So let's see if I can get in. All right, here we go. So I'm just gonna real fast to show off a few different things. This is basically the environment that you'd be brought into. And one of the things that I always like to show people is there's a JupyterLab extension in here that lets you monitor GPU resources. And assuming it loads up, you can actually see the GPU ticking here, but right now it's not coming up. So we won't necessarily, oh, there it is. So yeah, so I highly recommend pulling this up. You literally just have to click GPU resources and then you can click and drag it to the right. But if you're new to GPU execution, I love doing this just so that you can see what you're doing. And what we're gonna do, and you're more than welcome to follow along, is there's a welcome notebook. So inside the directory, welcome to BlazingSQL notebooks. If you just open up the welcome notebook, you can see what's going on here. So I'm just gonna give a second in case anyone's trying to follow along. Just open up the welcome notebook. And then we don't need to go through all this text here. This basically just does a little bit of explanation about the ecosystem and everything that goes on. We're just going to run straight to some actual work. So if you're familiar with PySpark or Spark at all, the Blazing context is basically are similar to a Spark context. It manages state of the engine and knows what's going on. And it's also where you kind of create tables, register storage plugins or external file systems, and do all sorts of different things. So we're just going to create this context. And once this context is done creating, which normally it should happen really quite quickly, but there might be something that's holding us back right now. Here, we'll give this just a second. While we're doing that, I wanted to see if there are any questions around getting up and running in here. All right. I think I know what's going on. This is a new server. We turned on a bunch of servers. And so the first time that it imports a package on one of the brand new servers, it takes a little while. So I'll just walk through what's happening here while we're waiting for it to bring all the packages in. But basically, we're creating this context. And once we create that context, we can start registering tables there. So with a create table, we put the name of the table, we put a file path as to where it is. And this actually isn't even necessary because it'll infer that there's a header row. And once we create a table off of this CSV file, we can just query it directly. Man, I was really hoping that this thing would have gotten running by now. Let's see. Just want to see.
I have a question that you can answer in the meantime.
That'd be awesome. Yeah.
So is it possible to place Blazing in front of Postgres? Is the question.
Yeah. So as of right now, not technically. I mean, there are ways to do it because we can run queries off of pandas data frames as well, assuming that you have a GPU on your server or on your computer. But that's the best way to do it. If you can do a Postgres query into pandas and then run a query off of that, that's great. Right now, the thing that we support creating tables off of are raw files and in-memory data format. So pandas, PyArrow, cuDF, etc. We've started opening up to things beyond just files. And the first of that is Hive. So you can actually pass a Hive cursor into the create table statement as opposed to a file path or a data frame, and that'll also work. So Hive is the very first one that we've enabled, but you can't do it on Postgres or MySQL or anything yet. So it just ran, so I'm gonna just show this off then. And for anyone else, you probably had that delay if you got put on a new server, and you wouldn't have had any delay if you were put on one of the older ones. But this is what a SQL statement looks like for BlazingSQL. It's literally just a bc.sql, also super similar if you're familiar with PySpark. You can put in your SQL into it. And then what actually returns here is one of these cuDFs or one of these data frames. So then you can start doing whatever it is that you want to do with one of these cuDFs. And just to kind of show that off, I'm going to start launching these in case. Just to show that off, right? The type of a query is literally one of these cuDF data frames. So if I have something that can plug into a cuDF data frame, that's all I need to be able to get it, just this bc.sql statement. And you can see as we're clicking and executing things here, I'll even do this again just to show it off, we see a spike in GPU utilization. And so that's how you know that if you've never run GPU code, you just did it, right? Like, hey, congrats. It's a big day for all of us. But going forward, right, you've got cuDF. So beyond BlazingSQL, there's more, right? So cuDF is the other package. Again, if you're familiar with pandas, this should all look very similar to you. But just like I was showing before, a BlazingSQL statement returns a cuDF. So this is how we can make a data frame as well with BlazingSQL. And you can do all sorts of things that you would expect pandas to be able to do, right? So you can do .tail, you can do .describe and look at the descriptive statistics on it. You can run, you can run filtering, just like you would on a pandas data frame. And all of this is happening on GPU, right? What's also really cool is because this data frame is this cuDF, it has a really nifty function called .toPandas. So if you're trying to enable cuDF to do things that aren't necessarily supported in the Rapids ecosystem, you can literally just convert it into a pandas data frame. So now right here, we have a pandas data frame, and you can run, .sample on it to grab some random rows. Taking it to DataViz. So I'm going to hope everyone's relatively following along if they're trying to follow along. So we're still in the welcome notebook, and now we're at the data visualization section. So again, if this is a cuDF and this whole thing is a pandas, and you're familiar with pandas plotting, or you like pandas plotting, which according to my breakout room, I don't think anyone liked pandas plotting, but I'm assuming somebody must enjoy it. You can literally just run, whoops, I don't know what sent me all the way up there. There we go. You can literally just run this command. And again, this is just a pandas data frame now in here. And you can start plotting BlazingSQL queries or cuDF data frames, however it is that you want to. Another really awesome project, Datashader. Datashader is one of the first projects that started integrating cuDF as a data frame that you can actually visualize and render visualizations off of. So here we're running a SQL statement off of the New York City Yellow Cab Taxi dataset. If you're not familiar with the New York City Yellow Cab Taxi dataset, it's just a big dataset of taxi rides, drop-off and pickup spots. And here we're literally just grabbing the drop-off coordinates and then rendering them in Datashader. And you can see that we don't do anything special to the data frame. We literally just pass it in as an argument to Datashader, and it knows how to render a cuDF. And so it's able to run. What's even cooler is it also knows how to render a Dask cuDF. So if you're doing this in a distributed context on lots of GPUs and the data set is dramatically larger, you can also be passing it one of these Dask cuDFs as opposed to a normal cuDF. And then the last one in here, and this is just like our welcome notebook to show things off very quickly. is QML. And so here, this is literally just for the sake of simplicity and trying to get people to do their first QML algorithm. This is, we're just doing a linear regression. And off of that same taxi yellow cab data set that we were talking about, we can extract the information that we need into data frames. This statement right here, I really like because it kind of shows how you can mix and match pandas functionality with SQL functionality to be able to get exactly what you want the way that you want it. And then here, let's just run that. Oh, it's going to have to bring this one in. So yeah, that's going to probably take a little while. So we'll just keep going for a little bit. Let me see. So yeah, there it is. So this is how we create the data set with QML, very similar to scikit-learn. We can do train test split so that we can break up that data set into training data and test data. And then we can basically hand that data off to this linear regression model, doing this fit and then this prediction on it. And so we just run it. Normally it doesn't take that long. I'm not necessarily certain what's slowing us down today. I think it's something on the storage layer. But you know what, we'll let this keep running for a second. But this is effectively what the whole ecosystem brings together, right? You have this cuDF data frame. You can generate it with SQL. You can generate it with pandas like API. You can pass it off to DataViz. You can pass it off to QML. That should not have taken, there we go. That's what it should have taken. It should have taken 34 milliseconds. Here, we'll just run this again real fast just to make sure nothing was weird. Yeah, there we go. So that's how fast that should have run. This is really not that large of a data set. And yeah, that's like a quick tour of the Rapids ecosystem. Like I said, this notebook application has everything you need to get up and running. We actually enable you to have either what we call Rapid Stable and Rapids Nightly. I highly recommend using the Rapid Stable build. This is basically every official release that comes out of Blazing, or not just BlazingSQL, but also the entire Rapids community. And it's just one that goes through a serious amount of testing. Rapids Nightly is the merging of all the PRs, building all the PRs that got merged that day. And so we do our best to run a series of test scripts for this app to make sure you have a good experience, but that's not guaranteed because it is a nightly build. So things can break all the time. But if you want to try the latest and greatest that's coming out of Rapids and BlazingSQL, this is the environment that you want to launch. So just to wrap things up real fast, this is a fully open source community. So first and foremost, GitHub, we're always looking for issues, feature requests, anything that breaks. It breaks all the time. It's breaking a little bit less today than it was breaking yesterday, and we hope to keep doing that over the next few years. But yeah, we actually had someone on this talk. I'm going to give a shout out. Ray Bell attended a talk the other day and put his first feature request for an issue in our GitHub, and we're super duper appreciative of that. But it's not just BlazingDB. Rapids AI also has a bunch of repos like cuDF, QML, etc. We also appreciate issues being filed there, and also Dask and the Saturn Cloud crew. I'm sure they appreciate Dask issues all the time. Follow us on Twitter, right? At BlazingSQL, at Rapids AI. Those are the big accounts. We post everything and anything that's going on in the ecosystem there first. Typically well before we have the time or energy to write a blog post about it. So if you're interested in knowing what's going on, that's a really good place. Slightly later than the stuff on Twitter is the blog itself. So blog.blazingdb.com. And we also have this Rapids Academy, which is basically a place for people to learn about Rapids and everything that's going on. So you can check it out at learnrapids.com. And yeah, just going over things real quickly about how you can get started. It's a Conda package. You can install cuDF, BlazingSQL, QML, whatever it is you want via Conda, and get started today. BlazingSQL Notebooks has this already. And we have AWS Marketplace instances that come with the whole Rapids ecosystem if you're looking to deploy it like that. And with that, I think that's time. So Yeah, I know I kind of went rapid fire. 30 minutes trying to go over a little bit too much content, probably, but I'd love to see if there are any questions.